I figure you know what the average of a data set is and know how to calculate it. You might not be familiar with the word mean, but that's just another word for average, so don't worry about that. It's a slightly more technical, slightly more correct term for the average. So we'll call this the mean, but we're still talking about averages here. You probably know how to calculate the mean. I expect that you know how to calculate the mean of a data set. It's a pretty simple operation. You add up all the data values and then you divide by the number of data values. Obviously, this only works if you're working with a quantitative variable. If you have a categorical variable, then its values are not numbers. They may be yes or no, true or false, something like this. And so obviously we can't add those up. But if we have a quantitative variable, then we calculate the mean by adding up the numbers and dividing by how many there were. So for example, if we have this data set, then we do 1 plus 8 plus 8, etc. And we get 60. And then we have to remember to divide by 10. And this gives us 6 for this data set. So take my word for it. You add up these numbers, we get 60. So that's easy. There is still, nevertheless, something for us to talk about when it comes to talking about the mean. The first is we need to introduce and discuss a special notation for the mean. Usually when we have a variable here, the variable has some symbol associated to it. It might be an X, it might be a Y. When we try to refer to the mean value of that variable, then we introduce the same symbol but with a bar over it. So if the variable is called X, then the mean is called X bar. So when you see a variable with a bar over it, particularly an X bar, this means the average of some sort of data set. And we need to know that because the X bar is going to occur later inside other formulas without explanation. You're going to have to anticipate, oh, that means the average of that data. So we have to get used to not only a new word for the same thing, but also a special notation that we have to recognize for that thing. Finally, we have to get used to this formula for the mean. So you don't need a special formula for the mean. If you know how to calculate the mean, then you know what to do. You take the values, you add them up, you divide by their number. But we need to understand the formula anyway, not so that we can perform that operation, but so that we can learn to read and decode other similar formulas. So the real content here, the real point is understanding all of the parts of this formula so that we can decode it and speak the language of this mathematics here. And so what we're going to do next is we're going to talk about this special formula for the mean, and we're going to see how it represents what we already know how to do. The first thing, we're going to sort of work from inside out on this formula. The first thing I want you to look at is the x sub I. When we have a data set, and here's a data series here. When we have a data series, we don't like to give every value in the data series its own unique variable symbol, right? This is X, this is Y, this is Z. I'm already out of letters. If I start over at A, then I only have so many letters and then I'll run out. So instead of giving every number its own separate letter so that we can refer to it, we choose one letter. In this case, I'll choose X, and then we label everything with an X, which of course causes confusion. So then we put a subscript on the X to refer to the individual data values. So X sub 1 literally means the first data value in the data series X, and X sub 2 means the second data value in the data series X. So these subscripted values refer to the individual variables here, the individual data values. That allows us to refer to them one by one in a way that makes sense. And if I write X sub 10, that must be the 10th, which is the last, which happens to be equal to 10. If we write X sub I with a subscript I, then this refers generically to the ith data value. So we take for granted here that if we're writing X sub I, then I is a number. It might be 1, 2, 3, it might be 10. And we're referring here to the ith in the list, number I along the data. So when I equals 4, this would refer to X sub 4, which is the fourth data value, which would be this 3. So that explains this notation here, X sub I. X sub I sort of refers generically to the ith data value. So this is really just referring to the data values here. That's what you see. So what about this crazy symbol? So this symbol here is a Greek capital S called a sigma, and it has a subscript, which is an I. So the capital sigma refers to the process or the the requirement to add up a bunch of values. Think of the sigma as an S and think of it as standing for summation. So we sum up the values, that means we add them up. So, and then the subscript I tells us, now if we were specific here, we could write I equals 1 to 10, and that would tell us specifically which data values. And if we are not specific and simply write a subscript I, it basically means consider all possible values that are feasible for the variable I in this context. So if we have summation over I of something, then this means add them all up. So this symbol by itself is incomplete. It says add them all up. Well, add what? Well, whatever comes after it. So in this case, these two symbols together refer to the process of adding up all of the data values, which is the first thing that we're doing when we're calculating the mean. So this refers to the data values individually but generically. And this refers to, basically it commands us to add them all up. So this says add up all of the individual data values. And then of course, this is just a simple fraction and we divide by n. Now n here traditionally stands for the sample size, which is the number of data values. In this example, it's 10 because there were 10 numbers in my data series here. So n is a symbol which has its own sort of loaded meaning, and we need to understand what is that meaning in the context of statistics. That's the sample size. And then finally, we have the equation x bar equals this, because this is now understood to be a formula teaching you how to calculate the mean. And x bar is a symbol that refers to the mean, and so it makes sense that this formula should be x bar is equal to that. So hopefully that helps you understand all the parts of this formula. Now that we understand how to decode the math in this formula, then we'll have the opportunity to introduce even more complex formulas and expect that they can be understood.